Hello everyone, welcome to a new video of NIOS Senior Secondary Course Mathematics. So we have already started this chapter, Relations and Functions, and you can see the content from the playlist. So we have stopped 2 months back, so we are restarting it from the topic 2.5, some special functions. So other topics you can get from the playlist, check it out there. And now the new topic is some special functions. Before going to the video, I would like you to subscribe to the channel. If you like the content, please give it a like and then share it with your friends. So the first special function that we are going to see is monotonic function. So what does this means is any function defined from a to b, it is said to be monotonic on an interval a b if it is either increasing or decreasing in that interval. Okay, so that is what the meaning of monotonic is. It should be increasing or decreasing. So how to understand what is increasing or decreasing in interval is, consider any function f of x cubed. If this is our function, it should be either increasing or decreasing. Let's find out how to do that. Let's draw the value chart like this and write x, and the function is f of x, that is x cube. Okay, so your value starts from -4, -3, -2, -1, 0. It goes on 1, 2, 3, 4 like that. And here if you find out the value, it will be 256 minus 4, the whole cube will give you 256, negative 256. Okay, here it will be minus 27, here it will be minus 8, here it will be minus 1, 0, 1, 8, 27, 256 again. Okay, so these are the values that you have got here. So what we are going to do is we are going to plot it in a graph. Consider this is your x-axis and this is your y-axis. Okay, split equal distance on the x-axis. Okay, and you will be getting equal distances on the y-axis as well. So it will be origin 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, 1, 2, 3, 4. Here it will be minus 1, minus 2, the negative numbers. So first value, if you check, it will be minus 4, minus 256. So minus 4 will be somewhere here, and minus 256 will lie somewhere very below here. Let's mark that point as A. Okay, so next point is minus 3, minus 27. So let's find out where it lies. Minus 3 and minus 27 may be somewhere here. Let it be the point B. Then minus 2, minus 8 may be somewhere here. Okay, we have not marked the rest of the things. So somewhere here C point. Then you can see minus 1 somewhere here. Then comes the origin. This is the one point. Then comes 1 and 1. It will be 1 and 1 here. Okay, D, E, then 2 and 8. If you consider, it will be somewhere here, F. Then comes 3, 27, 3 and 27 somewhere here. Okay, so we are plotting in that manner. Plot out all the points that you have got from the function, and if you make a graph out of this, it will be increasing. See here, I'm not able to draw it straight line. You can draw a straight line like this, joining all the plots that is available to you. And if you keenly watch the graph, you will come to know that it is an increasing graph. Okay, it is not a decreasing graph, it is an increasing graph. So in this case, you can call this as a monotonic function because the graph is increasing. Hope you understood what a monotonic function is. Let's move on to the next function, that is even function. So if you see what is an even function, it would be a function is said to be an even function if for each x of domain f of x and f of minus x are same. This is the condition that will be followed for even function. Okay, consider any function like f of x equal to x square. So when you find out x square, it will be f of x is x square. Okay, now consider f of minus x as well. So if you do minus x of x square also, you will be getting x square. Both the values are same. So in this case, you can call this as even function. Okay. Similarly, for cos x also you can find like that, and for an absolute value also you can find that. So this kind of function is known as even function. Okay. Now next, other examples of your even function can be x raised to 4, cos of x. These are the examples of your even function as well. The graph of even function looks somewhat like this. Okay, you can check this graph. Let's move on to the next function, that is odd function. So odd function's definition is f of minus x is equal to minus of f of x. Okay, this is the condition that will be followed for odd function. So if you see this x cube, see here x cube, you have to find what is value of f of minus x. So if it is minus value, that will be minus x cube. Okay, that will be equal to minus of f of x. This x cube is f of x. You can write it as minus of f of x. So this is what an odd function is. This is the definition of odd function. Okay. Similarly, check out this sin x as well, whether it is an odd function or not. A graph looks like somewhat in this manner. This is the odd functions graph. Okay. Next type of function is greatest integer function or step function, you can say. Greatest integer function, or you can say step function. It looks like a staircase. When you draw the graph of that, it looks in this manner. And what does it mean is, it will have the greatest integer that is near to the given number. For example, 1 will be the solution for 1 to 2. Okay, in this range, whatever you find, this will be the resulting value. That's why if you take from 1 to 2, okay, the value is 1. It is constant. It is not moving. It's not increasing. So this is the graph for different points can be plotted on this place. So that is all same. Next, when you find out 2, it will be from 2 to 3. So here so many points are there. Okay, so like that you can plot for each, and the resulting graph that you get will be somewhat like this. See, staircase type. So that is why it is known as step function or a staircase function. One is polynomial function. So polynomial function follows the form of a polynomial. It follows the form of a polynomial, which looks like this, where you have got x square, then x terms will be there, constants will be there. This will be the similarity of your polynomial function. Example, you can see here, f of x equal to a polynomial. F of x equal to a polynomial, where you have got x cube, x raised to 4, like that you will be having the values, okay, with constants as well. They are known as polynomial. So it has a form. Next type of function that we are going to see is rational function. So rational numbers, you already know what they are. They are in the form of p by q, where q is not equal to 0. So that is the form followed by a rational number. So a function in this form is known as rational function. So f of x equal to g of x by h of x, where h of x not equal to 0. It should not be 0, then it will be not defined. Okay, so both the values will be polynomials. Okay, the resulting function is known as rational function. For example, this is a polynomial, this is another polynomial, and here the value of x should not turn to minus 1. Why? Because if it turns to minus 1, the denominator will become minus 1 plus 1, that is equal to 0. Okay, so the denominator should not be 0. That is the only condition. So this is rational function. Next one is reciprocal function. So reciprocal function, any function of this type, y is equal to 1 by x, okay, where x not equal to 0. This type of function is known as reciprocal function. Okay, somewhat similar to your rational function, but they are not polynomials. Okay, exponential function, where the term e is involved and it can be elaborated like this in this format. Okay, it is found out by the mathematician Euler. And then this is an infinite series. You can see here like this it will be looking, and the function f of x is equal to e raised to x, where x is any real number, is called a exponential function. Okay, that is how an exponential function looks like, and the value of e raised to x is defined in this manner. Okay, this is an exponential function. You can see here how this works. This is a graph, value is taken like this, and the graph looks like this for this question. Okay, let's move on to the next type of function, that is logarithmic function. Let's see, here are all exponential functions explained. Next one is logarithmic function. Go through those, it will be easy for you to understand. So basic idea I have given. Logarithmic function means log functions, where you will be using the term log. Okay, it is inverse of exponential function. Whatever you have learned exponential function, inverse of that is known as logarithmic function. So apply log for that and you will get the solution. So here you can see function is y is equal to e raised to x. So after that the function can be written as x equal to log of e of y. So this is mathematically done, and then later you can write as y is equal to log of e of x. Okay, so that is inverse of exponential function. So graph looks somewhat like this. You can check here, this is for your exponential function, this is your equation, and then this is your log function. Okay, since it is inverse, the graph looks totally opposite to this graph. Next function that we are going to see is identity function. Identity function, it passes through the origin. Okay, graph of the identity function passes through the origin. It looks like this form, and then R is the set of real numbers, and a real valued function is defined from the relation given set of real number to that particular real number itself, to itself. Okay, so that is identity function, and the domain and range are the real numbers itself, and it is a straight line. The graph that you get will be a straight line like this, you can see in the picture, and it always passes through the origin. Okay, so next one is constant function. Next function is defined from a real number to real number, where you will be having constant value for the function. Okay, nothing will be there in terms of x also, you will be having only constant. For example, you can see this is f of x equal to 4. So what will be the value of 4? So 4, x value whatever it is, y value is 4. So when it is 4, it will be denoted on the graph like this, and it will be a straight line. You will be getting a straight line as the result. Okay, which is parallel to your x-axis. Fine, this is how a constant function looks like. Let's go to the next function, that is signum function. What signum function is the last function that we are going to see. Function is defined from the real number to real number, where you will be having 1 if x value is greater than 0, 0 if it is 0, x is 0, minus 1 if x is less than 0. So this is known as signum function, where the domain is only the real number, and the range, that all the values that you get for the range is 3 values, minus 1, 0 and 1. A graph looks like this, where you have got y is equal to 1, y equal to minus 1, and the value 0. Okay, so this is the signum function. So if you liked this video, don't forget to give it a like, subscribe to the channel, and thank you for watching. See you in the next video.